Alright, we're going to start the next page on the law of sine. So let me just zoom in a little bit so that we can see it a little better, and we will start. Okay, so on the next page of law of sine, the word problems get a little more, there's a little more complexity to it. But the good thing is they have given us the diagram, so it makes it easy. So let's go ahead and read it first. As always, the reading is the biggest thing. So here it says an airplane A, that's the here, airplane A, takes off from carrier B. So carrier B, so it takes off from here, flies a straight line of 12 kilometers. So it goes from B to A, the flight goes from B to A and it travels 12 kilometers. That's what's important for us, this distance. At that instant, an observer on destroyer C, that's this point, located 5 kilometers from the carrier, so that's what's important to us. So this is also 5 kilometers. I like to write my unit of measurement so that when I write my answer, I can do that too. Notes that the angle determined by the carrier and the plane is 37 degrees. So this is 37 degrees. So even without reading too much into it, because this is marked as 37 degrees, I know this is 37 degrees. Okay, so how far is the plane from the destroyer? How far is the plane from the destroyer? So we're trying to find this distance, because this is your carrier, this is your destroyer, this is your plane. So how far is it from the destroyer? So anyway, if they're asking for a distance, this is the only distance that's missing. So this is what they're asking for. So the question now is, I cannot use my right angle trigonometry, SOHCAHTOA or Pythagorean theorem, because there's no right angle. Right now I cannot see any right angle. So I try to fall back on my law of sine and law of cosine. But law of sine, that's what we're learning right now. Can I use a law of sine? I think I can, because I see an angle and a side opposite that given to me, which means I can start setting it up. I can say sine 37 degrees over 12 kilometers, just 12. Let's just write 12. No, we don't need to write the unit of measurement. And then the only other piece of information that I have is 5 kilometers. So that is opposite angle A. So what's going to be missing here is an angle is going to be missing here. I'll have to find angle A to be able to set it up. So basically I'm going to say sine A over 5. Why am I doing this? Because for me to find side B, first of all, the only other piece of information apart from these two is this. So I'm going to use that. The second thing is, for me to find side B using the law of sine, I need to know the angle B, because you need to know the opposite side for you to be able to solve this. So I'm going to solve for sine A, or I'm going to use sine A, but I'm going to solve for angle A. So how do I solve for angle A? You use this, do your cross multiplication. So sine A is going to be 5 times sine 37 degrees, and basically cross multiply over 12. We're good? So cross multiplied, and then 12 stays as it is, because you want sine A by itself. So now my question now is, how do you, so your goal is to get this, your answer cannot be sine A, it has to be angle A. How do you get angle A by itself? How do you so basically when you move the sine over to this side, what happens to it? It becomes sine inverse. So angle A equals, this is where the inverse comes into play. So always keep in mind, the inverse is used to solve for an angle, the input is a ratio, the output is an angle. So you're going to do sine inverse of this, and you're going to put this whole thing in the calculator. Over 12. Please put this in the calculator, and you should see angle A equals 14.522 degrees. So hopefully everybody is comfortable using the calculator, and you should be able to put this in your calculator and find it. Okay, now that I have angle A, so angle A I just found out to be 14.522 degrees, and let me just highlight this to just to show that we solve this. And now that I have two angles, so now I can easily find angle B. Can you guys pause and think about this and see why you can find angle B? Because you have two angles in a triangle, and you can always find the third angle. So angle B equals 180 degrees minus the two angles, 37 degrees plus 14.5 2, which is equal to angle B equals 128.478 degrees. So that's my angle B. Angle B is 128.47. So I found out this also. Now it's easy for me to set up to solve for B because I have the angle opposite, so I can side B is the only missing one, and I can use the same thing on the same this side for another ratio. So remember, in a ratio you need one whole ratio and one on the other side. So I'm going to set it up as sine 37 degrees over 12. You always need one whole ratio, and the other one, just one of them. You should need to have, and you can solve for the other. And for you to find side B, you will use this angle, and this angle will be sine 128.478 degrees over side B. Now get B by itself. You'll cross multiply. When you cross multiply and get it set it by itself, it will be, at this point you should probably hit pause and just try to solve it by yourself, because it's just cross multiplying and getting B by itself and putting it in the calculator, and just check your answer. So I'm just writing down sine 128.478 degrees, the whole thing divided by sine 37 degrees, and there we go. Hopefully you're also able to put all of this in the calculator and get all of this. There's just one thing I want to talk about, just something for me to bring up. So you see that side B is the longest side. It's 15.61. And what do you notice? The angle opposite that is also the largest angle. So remember the theorem we learned in geometry, the hinge theorem, which says larger the angle, larger the opposite side. So the wider you open the door, the bigger the angle, the longer the side. Okay, and the smallest side will have the shortest side opposite that, basically. The longest angle has the longest side, and the shortest angle has the shortest side. Okay, so let's now go to the last example of this section, and then we will close this section. And so let's look at this, and we will start. Okay, so this one is there's a little more complexity to it, even compared to the previous one, but let's go ahead and read it. A plane flying in a straight line passes, so this is my plane, it's flying in a straight line, and what it's says is it passes over point A, point B, and directly over point B, which is 3 miles from A. So this is 3 miles. This is 3 miles. A few minutes after the plane passes over B, the angle of elevation from angle A is 43 degrees. So this is 43 degrees. And the angle of elevation from B is 67 degrees. How high is the plane? So when it is at this point, how high is the plane? So remember, the height is always a straight line. So basically so even though this is what is actually given to us, what they're asking us for is this height. So this is what we need to find. What we notice here is this is a right angle triangle. So I will be able to use either Pythagorean theorem or SOHCAHTOA, or any of those things. But I don't have enough information. I just have one angle. Obviously the 90 degree does not help us in any way. I do have the angle theta, and I have to find the side opposite that, which is basically going to be the opposite side. But I don't have the hypotenuse, or I don't have the adjacent side. So if I can find one of them, I can actually use SOHCAHTOA to find so I can basically use sine, actually, because opposite side is what I need to find, and hypotenuse, if I can find A, and looks like that's what I should be aiming at, because they've even given us the alphabet. So my question now is, how do we find side A? So we are going to be looking at this triangle. We are going to be looking at this triangle. In this triangle, what are the pieces of information I have? I have, this is 3 miles. This is 43 degrees. Unfortunately, I don't have enough information to set up the law of sine, because this is my side, I don't have an angle opposite that. This is my angle, I don't have the side opposite to that. But I have this as 67 degrees. I do have this. So how will I use this? Remember, this is a straight line, and a straight line is always 180 degrees. That means this one is going to be just this angle. this angle is going to be 180 degrees minus 67 degrees, which is, remember, you guys remember this linear theorem? Linear theorem is any straight line is always 180 degrees. So if this is 67, this will be 180 minus 67 degrees. Therefore, it is 113 degrees. So this is 113 degrees. Bingo. Now what do I have? I have two angles of this triangle that I have highlighted. Whenever you have two angles, you can always find the third angle by subtracting from 180 degrees. So this will be 180 degrees minus 43 plus 113, which gives me 24 degrees. So this becomes 24 degrees. And now what do I have? I have an angle and a side opposite. So that means I can do sine of 24 degrees over sine of 24 degrees over the opposite side, which is 3, equals, now I can find side A because I have angle this angle. So sine 43 degrees over A. Is everybody good so far? Do your cross multiplication, hit pause, do your cross multiplication, get A by itself, and you should get A to be 5.03. You should get A to be 5.03. I just found out that because of this cross multiplication. Now what do I have? Now actually I have a right triangle with one angle and one side, which is the hypotenuse. So we're talking about this right angle triangle. And what do I have in this right triangle? I have one angle, that's my theta, and I have the opposite side. This is my opposite side, sorry, OPP. This is my opposite side. A is the hypotenuse. So which one uses opposite and hypotenuse? It is sine. So I use SOHCAHTOA sine 67 degrees equals opposite, which is what I'm trying to find, over hypotenuse. I just found out the value of A to be 5.03, and get H by itself, and H equals sine 67 times 5.03, which is 4.63 miles. That's your answer. Alright, hopefully you got this. I am going to stop this, and this lesson is over.